Okay guys, we've been looking at different types of functions and now we've moved on to exponential functions, and a few reminders, a few things to look at. Well, x, it's in the exponent, and here I have it listed as b to the xth, and b represents that base value. But if we look at the general form, or the form of an exponential function, well, a sub 1 times r to the xth, r is the same thing as b here, so it's just our base value. When looking at this, this function here, well, a sub 1 cannot equal 0. R has to be a value greater than 0, and R cannot be equal to 1. R does not equal 1. When you're looking at the graph of an exponential function, that line bends, so your line's going to bend. Alright, you could have exponential growth, which means that your input value, as your input value increases, your output value also increases. If you're looking at exponential decay here, it means that as your input value increases, your output value decreases. So what you're going to see in these two graphs is, well, as x increases, y increases for exponential growth. For exponential decay, it's saying as x increases, y decreases. So let's move forward and look at a few problems here. Alright guys, in this first problem we're asked to create a table for the exponential function and use it to graph the function. So I'm going to create a table for this function first. So let's say, alright, so I have x, or my input value, on the left hand side of the table, and for my output value, you could think of it as y, or since I have f of x here, I'm actually going to write f of x. Okay, so now I'm going to choose values for x. I'm going to substitute some values in. So what if x is negative 4? And I'm going to fix that negative symbol. Negative 3, negative 2, negative 1, 0. I'm going to say 1 and 2, and I can build on further from there if I need to, but I think this will be a good place to start. Alright, so when x is negative 4, I'm going to do that workout here. I'm going to say f of negative 4, is equal to 3 times 2 to the negative 4th. Alright. So order of operations says work exponents first. I have a negative exponent, so what I'm going to do right here, I'm going to actually flip the reciprocal of my base to make this exponent positive. So now what I really have is 3 times, well, what I have here, 2 as a fraction would be 2 over 1. So to flip the reciprocal, I'm going to make it 1 over 2. So I have 1 over 2, and now my exponent's going to be positive. It's not going to be negative 4. It's going to be positive 4. Okay. Okay, so 2 to the 4th power. 2 to the 4th power is the same as 16. So I have 3 times 1 over 16, and now all I have to do is multiply 3 times 1/16, and 3 as a fraction is 3 over 1, so all I'm going to do is multiply straight across on top. In fact, I'm going to fix that arrow, straight across on top, straight across on bottom. In fact, I'm just going to get rid of the arrows, and I'm going to get rid of that fraction, so 3 times basically 1 here. So this is equal to 3/16, which means that f of negative 4 is equal to 3/16. So that's equal to 3/16. I'm going to fix that 6. In fact, I guess it's not really that important because I'm just going to rewrite it up here. 3/16. And I can take this and just kind of box it up right now if needed. And I'm going to jump into my next value of x, which is negative 3. So now I have f of negative 3 is equal to 3 times 2 to the negative 3rd. And now I'm going to rewrite this to create a positive exponent here, to make it a positive 3. So now I really have 3 times 1 over 2, and I'm going to lower that 2 just a little bit, 2 to the positive 3. Alright, so simply 2 to the positive 3 is 2 times 2 is 4 times 2 is 8. So I have 3 times 1/8 here, and now all I have to do is multiply 3 times 1/8. So here I have f of negative 3. Negative 3 is equal to 3/8, and I'm going to take 3/8 and just write it up here, 3/8. So when x is negative 3, f of x is 3/8, or you can think of it as y is 3/8. All right. All right, so let's look at -2 when x is -2. So f of -2, it's equal to, well, 3 times 2 to the -2. All right. So now I have 3 times 1 over 2 raised to the power of 2, and 2 to the second power is 4. So I really have 3 times 1/4. So f of -2 is equal to 3/4. So write 3/4 here. And I'm actually going to box that information up too. There we go. When x is -1, so f of -1 is equal to 3 times 2 to the -1. So now I have 3 times 1 over 2 to the first power, which is simply 2. So we have 3 times 1/2. And 3 times 1/2 would give me 3 over 2, or I could rewrite this so that it's f of -1 is equal to 1/2 here. So we have 1 and 1/2. And box that up. All right, so now we have f of 0. F of 0 is equal to 3 times 2 to the 0th power. All right, so well, anything to the power of 0 is equal to 1. So simply 3 times 1. So f of 0 is equal to 3. All right, so when x is 0, f of x is 3. And let's box that up. All right, so now we're looking at f of 1, which is equal to 3 times 2 to the first power. So we have basically 3 times 2. So f of 1 is equal to 6. All right, so finally f of 2. F of 2 is equal to 3 times 2 to the second power. So I have 3 times, well, 2 to the second power is 4. And 3 times 4 is 12. So f of 2 is equal to 12. So we have 12. And now what I want to do from here is get rid of all that information. Now the next thing I'm going to do is actually let's get rid of all this information because I want to graph this function. Alright, so let's get a coordinate plane up on the screen. Alright, and let's get some tick marks down here. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I'm going to go 1, 2, 3, and 4. Alright, and then I'll just put one down below for convention. Alright, and now I'm going to actually label my scale here. So 1, 2, 3, 4, -1, -2, -2, -3, -4. Then this would be -1, and so on. So +1, +2, +3, +4, 5, 6, 7, 8, 9, 10, finally 11, and 12. 12 at that very top tick mark there. So 12 here. Let's go ahead and graph these ordered pairs. Okay, so the next thing I can do before I even graph the values in this table, I can look at the relationship between my input values and my output values. And again, you can think of f of x here as your y values. So as the input values are increasing from 0 to 1 to 2 and so on, as they're increasing, as these values are increasing, your output values are also increasing from 3 to 6 to 12 and so on. So as these values are increasing, your inputs are increasing, your outputs are increasing. Another way of thinking about it is, well, if you're thinking of f of x as y, well, as x increases, y increases. So I can actually plot these as ordered pairs now. So -4 and 3/16. So when x is -4, I'm going to have 3/16. It's going to be close to this x-axis. It won't be touching it. And then when x is -3, y is 3/8. So a little bit higher than the last point. Again, these aren't perfect. I'm just eyeballing it. When x is -2, y is 3/4. So probably somewhere around here. Again, just eyeballing it. And when x is -1, y is 1.5. So when x is -1, y is 1.5. So somewhere about here. In fact, I'm going to make that just a little bit higher. All right. When x is 0, y is 3. So y is 3. When x is 1, y is 6. Notice how this is starting to grow quickly now. So when x is 2, y is positive 12. And that's the last point I'm going to plot. So y is 12. It's way up here. In fact, that's probably a little bit too high. And I might be a little bit off on my graph. I'm just eyeballing this. So let's see. I'm going to say that's close enough. And now what I'm going to do is try to draw a straight of a line or a line through all of these points. So this line, it's going to curve. The line is going to curve. It's going to pass through these points. It's going to pass through all of these points and can't make it perfect. And it's going to start to grow rapidly. And it's also going to move in this opposite direction. And in fact, what's going to happen is this line, as it moves further away from 0, this line should get closer. I'm actually making it a straight line so I don't run into the x-axis, but it should actually get closer and closer to the x-axis. It should get closer to the line, but it will never approach 0. It won't touch 0 in this function here. So we can see that well. Another way of looking at this curve here is that it starts level and then it grows rapidly, and we call this exponential growth here. Exponential growth. Cool stuff.